to be able to answer for us in the end of the today's session. We'll have Q&A session when all the questions will be answered. And the topic of today's session is visual GenAI. Overall, GenAI is tremendous success, especially in large language models, but it influence extends on other modalities like visual domain. It works across different industries from retail to automotive with ability to create tailored images, generate images, and technologies like Stable Diffusion already have emerged and enable some of this use case. So I hope today our speakers will dive you into those multimodal opportunities and tell what are the technical side of and what are the limitation of current technologies for those use case, as well as how it might be tailored for different business opportunities. And let me introduce our speakers. Our first speaker is Taras Rumizhak, who is R&D GenAI lead. He has experience both in commercial and research experience in computer vision domains. He collaborated with University of Oxford and successfully defended his master thesis on the visual GenAI topic for automotive use case. And his team trained more than 500 hours for custom models, GenAI models for commercial use case, as well as has and gain technological perspective on visual GenAI and wants to share it today. The second speaker is Sheremetieva. She's the senior R&D product manager. She's specialized in deep tech commercialization. She's the author of really impressive demos and immersive experience like Fortune Teller is a touching story, and recently launched the immersive experience as a SoftServe immersive experience as a service by SoftServe, which is frequently based on unique technologies and emerging technologies like generative AI. So, guys, stage is yours. I encourage one more time, you ask the question. We'll track all of them and we'll answer in the end of the session.
So I'm going to start sharing the screen.
Yeah, great. So I will start. My name is Taras, and Bogdan did quite a well introduction. So let's briefly touch the agenda for today. So at first, we will start with the introduction of visual GenAI direction of technologies. We will also start describing like diffusion models and especially Stable Diffusion. We'll also touch their technical capabilities and existing challenges with this recent technology. Then we will provide like a market overview and potential applications that we are working on and that are interesting for the industry. Let's go further. Yeah, so let's start with the introduction. And the first definition is actually definition of generative AI. So the simple definition of generative AI is just a type of AI, of artificial intelligence, that allows us or machines to create new content. It can be different content like images, audio, text, etc. And for the inputs for the generative model, they can be text, image, video, or even nothing, like noise, something like this. And as the output of a generative model, we will also receive text, images, videos, 3D data, etc. Let's move forward. And let's start this conversation with just like declaring some specific boundaries between GenAI, LLMs, and visual GenAI. So generative AI is a broad category of AI, which includes different topics. And LLMs are quite popular. And within SoftServe's GenAI lab, we have great experts in LLMs responsible for working with textual data, and we have great use cases for that. But today's session will be dedicated to the visual GenAI. And it refers not to the text, but to the visual content like images, videos, 3D data. And here on the diagram, you can see that generative models are part of neural networks, and LLMs and visual GenAI models are both parts of generative models. And let's move forward and touch brief history of generative AI with specifically for the topic of visual GenAI. So everything started with the origins from 50s to 90s, like in 1956, the field of AI was created, and this AI definition was developed, and then the perceptron, the original, let's call it first version of neural network, was developed in 1958. And then in 1998, Jan LeCun created the convolutional neural network, responsible for working with visual data, and it was a huge step further to the computer vision and generative AI in visual domain. Then from 90s until now, the next step in evolution of GenAI was autoencoders. So the idea is just to encode your images or any other data to some latent space, then decode it. And so while learning this, the models were capable of generating new data. And the interesting step there was 2019, when VQ variational autoencoder 2 was presented, and it was able to generate a very high quality images, and that's where all the competitions of guessing if the picture is real or not started. And then in 2014, GANs, generative adversarial networks, were introduced by Jan Goodfellow and his team. And it was also the next great step in the evolution of visual GenAI. Different works were developed in this direction. In 2019, NVIDIA presented StyleGAN. It's actually, they added the capability of controlling the generation of faces, and those faces were like, they looked like real. So let's move forward. And the interesting step is actually starting from 2021. It's a presentation of Stable Diffusion model, very popular model. Then in 2022, just recently, commercial models like DALL-E or Midjourney, they exploded the field. Everyone started using those models. And in 2023, this similar to StyleGAN, like Zhang and his team added the capability of generating conditional dependent images. So we have some control over generation. And actually, next steps, like for our team and for other developments, is so we are here right now. There are still a lot of problems with Stable Diffusion. We will touch them, like resolution, training, inference, and we are here to resolve them, and we are trying to do it right now within SoftServe's GenAI lab. And let's move forward. What's actually Stable Diffusion? It's a GenAI model that performs text-to-image generation. And for now, we have a great audience, and we just created like a simple prompt, like teddy bears in futuristic clothes watching a great presentation about generative AI. And it looks very cool. It's definitely have a correspondence to the prompt, and it's just magic. And let's move forward. But for example, our audience is growing since the beginning, and we also have audience in the Facebook live stream. So we want to add, to personalize previously created image, and we want a larger stage and a large audience. Not a problem. We are just incorporating this in the prompt, and we are getting different image according to our needs. Also, I want to create the different image like in the cartoon style, and I want a round table. Also not a problem. We're just incorporating this into the prompt, and GenAI is generating this. So basically magic. And now let's start talking about the diffusion model and especially how I explain it to my wife. So I will try to be non-technical. Let's move forward. So here you can see a nice animation of the paint or ink drop to the water. It looks nice, but actually there are great physics processes behind this, and they were the inspiration for the diffusion models. So actually in physics, diffusion is just a movement of anything, like it can be molecules, atoms, etc., from a region of high concentration to a region of lower concentration. And on the right side of the slide, you can see that those orange dots are mixing with the black dots. And this is important process. Keep in mind this because we will have references to that on the future slide. And let's move forward. In diffusion models, the main step, there are two main steps. Actually, the first one is forward diffusion, and the next one is backward diffusion or reverse diffusion. In forward diffusion, as you can see here, we are just adding noise to the original image. So here you can see my image, and during this forward diffusion, more and more noise is added to my image until the moment then we will just have noise and the picture will be indistinguishable and you won't be able to tell if it was me. And the reverse diffusion on the next slide is okay, and here important things that, for example, if we have the images of myself and images of Anna for forward diffusion, the idea is that all of the images will be generated to noise, and we won't be able to tell who was on the original image, me or Anna. And that's why it's called diffusion, because I'm referencing to the slide with the ink drop. When you drop the ink to the center of the glass of water, it will still distribute equally in the water. And also, if you drop the ink on the corner of the glass, it will still distribute equally. And you won't be able to tell where was the original point of drop. This is similar to this example where you won't be able to tell who was on the original image, me or Anna. And let's move forward. And here is actually the next step is reverse diffusion. And the idea of the reverse diffusion step is actually to reverse what we've done before, and from the noise generate the original image. And this is like the interesting and hard task. And in theory, diffusion models are capable of solving it and learning the noise predictor in such a way that it will be able to generate original image from noise. But that's only in theory. So let's move forward. How this is done in theory? We are generating random noise. We are corrupting the original image by adding that noise to the image. It's a part of forward diffusion. Then we are teaching the noise predictor. It's a special part of Stable Diffusion, some network that will have one task: understand how much noise was added. Then we are generating like a random noisy image. And with noise predictor, we are starting predicting noise that it was learned before and start subtracting the noise from the original noisy image. And the idea of that, if we subtract the noise from noise, and we will repeat this for a few times, we will be able to get the original image, as you can see here. But this is only in theory. Let's move forward. The problem with this approach, with diffusion models, is that even a small image of 512 by 512 pixels, and we have RGB colors, it will have a lot of values only for one image. And it's computationally very expensive. But there is a solution for this. And we were mentioning the history of GenAI, and we mentioned variational autoencoders. The idea of this is that it's a special type of network that has encoder part and decoder part. The idea is that it takes as input the original photo, for example, of myself. It shrinks it to become a vector, just to represent it with some numbers, and it gradually shrinks it to have to be very small. It won't be image anymore. It will be just like a small representation, numerical representation of the image, and this small representation will be in this latent space. And then the task for decoder will be to transform this small representation of the image that keeps important information about the original image, just to replace it back by the original image, gradually extending its resolution, and we will obtain the original image. So that's the idea of latent models. And let's move forward. And here is the interesting part, is actually Stable Diffusion. For the training of Stable Diffusion model, a lot of like a huge data set was used, but all of the samples from the data set are just textual and images pairs. So for example, you have an image of the cat and you have corresponding prompt text called cat. Or if you have an image like cat sitting on the grass, you will have like the corresponding pair. And for long training time, it computes, it learns the distribution of the noise, it learns the noise predictor, it calculates the latent space, optimizes the model. And let's move to the next slide. And here you can see that during the optimization, during the training, for the first iteration, it's not able to generate something nice. But on the iteration number 100, it starts generating something similar to a cat, but still not perfect. And then after a significant amount of iterations, we start seeing great images of a cat, and we cannot distinguish it from the real images. And let's move forward. Of course, as we described previously in the theoretical diffusion model, Stable Diffusion works similarly. So we are adding this noise gradually to the image in the forward diffusion step. And during optimization, we are learning this noise predictor for the reverse diffusion step. Let's move forward. But the difference from the theory and practice is that Stable Diffusion uses latent space just to be able to apply theory in practice with taking into account different computational constraints. So instead of adding noise to the original images, we are adding noise to a small representation, latent representation of the image. And so the theoretical idea is almost the same, but computationally, it's much easier for the network to learn and to optimize. And as you've seen, it's also like encoder-decoder architecture. So it will be able, so it shrinks the image to the latent representation, adds some small latent noise, and then decoder increases the size and resolution of the image, and back we will have the nice, great image of the cat. Let's move forward. So yeah, we described the noise and how it works, but actually, what about prompting with how we can incorporate text to image? I won't dive too much into details, but just a general understanding. So we will have a text prompt, just a photo of a cat. In order for computer and for neural network to understand this text, we need to somehow transform this to be to the corresponding format. So we use tokenizer. So we are actually transforming those words to some numbers. And then another part of Stable Diffusion, some embedding subnetwork, it transforms those numbers to a 768 value vector. So it will be just a numerical representation of that input prompt, of that sentence, of that text. And then text transformer combines all of those vectors, because one vector is a representation only for one token and one word. in order to understand the whole sentence, the whole prompt, and like people like to include a lot of information in the prompt, we need this text transformer. It's another subnetwork that will understand it and put this additional information to the noise predictor. In that way, in the noise predictor, we will have two inputs. We will have the image to add the noise or to subtract the noise, and we'll have this additional information encoded in a matrix or those vectors. Let's move forward. And how it looks like on our diagram. So during each of the forward diffusion and reverse diffusion steps, we will just have this image description, this text. We will incorporate this output of the text encoder to each step of the forward and backward diffusion. So it will be just additional matrix that represents the original text. Let's move forward. And here you can see that this text prompt is incorporated among different steps. So it's not just once. Every time during each step of noise predictor, you will have this text prompt incorporated. So let's move forward. But the interesting stuff begins not only with text, but also with some additional control information. For example, input image. I asked my wife to draw a cat. This was the result. And we can use this cat as an input to diffusion model. And with this information, even without cat prompt or just with this conditioning, we will be able, like the Stable Diffusion, will be able to generate the cat, which will look similar to this drawing of the cat, something like this. And on the next slide, you can see that this is actually the idea presented by ControlNet that we mentioned during history. And the great thing about this is that we can use edges or sketches, drawings, something like this. We can also use human pose just as the input to Stable Diffusion to generate the desired images with some additional information, not completely random, but with incorporated conditioning. We also can use segmentation map and generate the image of the house. And we can also use a depth information also to create some nice images. And it really creates a lot of opportunities and different use cases for this. Let's move forward. Besides ControlNet, there are a lot of more extensions for the Stable Diffusion, and we divided them to 4 different directions. The first one is control, like different conditioning, modalities, style transfer, something like this. Also fine-tuning. Of course, you can fine-tune Stable Diffusion and specifically to your business needs, specifically to your data set, specifically to your products, use cases, to your data, and fix some problems of general models. And according to efficiency, some extensions are just to increase decrease the inference time or improve the efficiency of training. There are multiple approaches, and we are working also in this direction. And just general extensions, it's just to create high-resolution images, to create vector graphics, or create 3D objects. And let's move forward. Let's just touch technical capabilities of Stable Diffusion-based models. The first one is very cool. It's denoising and super resolution. So it reminds like a lot of those like Snapchat filters or something like this, when you, for example, can create like a smoother skin or smoother background, or if you have some family pictures back from 2007, something like this, and you want to restore them in the great quality fitting to today's standards, you can use Stable Diffusion for this, and even from the box. But of course, within our GenAI lab, we are working on improving this to create images of 4K, 8K, and improving the quality of the results. Let's move forward. Another amazing feature is in-painting and out-painting. So imagine you have an image of the dog sitting on the bench, and like your relative or your friend doesn't like dogs, so you want to replace the dog by the cat. you can just erase the part of the image with the dog and create a prompt that it's a cat sitting on a bench. And with this, as a result, you will get a cat sitting on a bench. Magic. This was in painting. And for out painting, imagine you have the image of a cat sitting on a bench, but only a small, tiny amount of the data, or a small portion of the image. And you want to extend this image and create a larger image. So you can just also use Stable Diffusion, and out of the small image, you can generate a big image, out-painted image of the cat. And let's move forward. Style transfer is an important and very famous direction. It was used in GANs a lot, in variational autoencoders, but in Stable Diffusion, it also works perfectly well, especially with prompting features. So you can create the same image and make it more realistic, or make it in a style of different artists, for example, or you can use it for different use cases for your business if you want like some local content for one market, or like from Middle East to Europe, something like this. Let's move forward. Video generation. It looks quite cool because you can generate different frames and combine them to the video, and they will have like this smooth transition, not that smooth, but still a great application. Let's move forward. So on previous slide, we've seen not that smooth transition, but it was the result obtained with original Stable Diffusion. But I mentioned that there are a lot of extensions, and we are also working on some extensions. And one of them is Stable Video. So with Stable Video, we're able to generate or adapt original videos, and for example, to change the color of the sheep, or change the original video to the sunset. And it's pretty amazing. You can use this for different animations, also for localization, just for augmentation of your data set. So a lot of different use cases, and it works pretty smoothly. Let's move forward. And also like pretty great technologies generating 3D objects. So Stable Diffusion by itself, and like the common approach in recent months was just to use Stable Diffusion to generate multi-view images. For example, like this avatar of cyberpunk girl with the pink hair. We can generate consistent multi-view images, and then using some other technologies like NERF, combine them to a single 3D object. And here are the results from the original paper. And on the right, there are also some results from our GenAI lab, where we were generating some shoes. So it's also pretty impressive. You can use this for game assets creations, also for marketing materials, and so on. Let's move forward. It's also one small example. So anomaly detection, like a classical computer vision task, and Stable Diffusion is still capable of solving this task. Of course, maybe it's overhead to use Stable Diffusion for this, but still it shows how powerful this visual GenAI is. So you can find some anomalies on the images. So this is a pretty simple example, but you also can use this in manufacturing to detect some anomalies on like car production or in PCB boards, etc. So Stable Diffusion is still capable of this. Let's move forward. And yeah, this was just a funny slide. So you have unlimited creativity, and I asked my team to generate, we had a competition who will generate a better variation of my photo, and those were the 4 winner pictures, like in the style with some makeup, with cartoon style, with Barbie style, something like this. So this is pretty impressive. Let's move forward. Generally, there are a lot of pros of using visual GenAI, Stable Diffusion based models. It's like really high quality samples. You can control them. Those are very flexible. You can use transfer learning and for different tasks, anything you want. But of course, there are problems. And those problems are actually the things the reason why you cannot use Stable Diffusion original model just from scratch. it's a computational expensive. It has a large training complexity. It's hard to interpret the results, and it has some data privacy issues. The inference speed is also not the best, and it's hard to scale. But fortunately, within our GenAI lab, we are aware of these issues, and we are working in these directions, and we have some achievements in resolving those issues. Let's move forward. Here we are just quickly touch some challenges of the regional models. Let's move forward. For example, low resolution generation. So Stable Diffusion is capable of generating 512 pixels. With Stable Diffusion XL, it was increased to 1024 pixels, and Midjourney is capable of the same resolution. But sometimes it's not enough. Like, people want 4K, 8K content, and for this we need to think to what to do with this. And we are working in this direction. We partially resolved this problem in some of our projects. Let's move forward. Another interesting defect is actually hallucinations. So sometimes it's hard to, like, the model doesn't have the reasonings and the logic of the generation. So it just learns distribution of data, but for example, with Hugging, or it has like just too many hands. And sometimes it's also the problem with generating like hands with 6 fingers. Of course, they are resolving this, but they are resolving this by training on specific data, not by reasoning. So this is still a challenge. And so let's move forward. With this content consistency, still sometimes without using specifically developed extensions, it's still not the same cat. You can still spot the difference, and generating consistent content requires some effort and time, and we are working on this. We can help with this, but with usage of original Stable Diffusion, it will be hard to do this. And let's move forward. And now I will give the word to Anna.
Thank you, Taras. So now, guys, as you learned all the technicalities, I would like to share with you some market insights, very high level. So we'll start with a market size. There are actually a few market research regarding image and AI, but I use the research results by a consulting company called Global Market Insights. I use their research results, and according to their research, image GenAI market size in 2022 was valued almost to $140 million US. And within the next 10 years, it is projected to grow with a growth rate of 16.5%, which is amazing growth. And this growing trend actually is observed for both GenAI software and GenAI services. You can see it in the right bottom image. Also, analyzing the image GenAI market by industries, we're getting quite straightforward observation that 2/3 of market share goes to very image-dependent industries such as retail, e-commerce, fashion, and media and entertainment. And actually, we used these insights to prioritize our work and use cases. So we see the intense market growth, but what driving it? There are some technical and business reasons. For instance, development in tech made image and AI possible, actually. So rapid progress in deep learning and AI has improved AI image generation. For instance, deep learning platforms like TensorFlow, PyTorch, and Keras, they continue to evolve and improve, and thus offering the enhanced capabilities for improving, developing AI image generator models. Innovations in neural network architectures, such as generative adversarial networks, have led to another amazing possibility, generation of high quality and realistic images, which are the kind of must for most of the target industries like retail, marketing, etc. And of course, anything can happen about without cloud computing. So when it comes to the business drivers, increasing demand in high quality visuals content across industries empowered the need for cost and time effective generative solutions or platforms. Again, the rise of e-commerce and online shopping has increased the need for virtual try-on experiences and personalized visual content. Raising number of social media users made business require like more content to reach their audiences on different platforms. Even NFT was named as a GenAI, image GenAI market driver, as it has increased the demand for a new exclusive digital assets. If adoption of visual image GenAI be that easy and seamless, every business would be using it as of today already. However, there are a lot of concerns you can see on this graph. Among the first factors, complexity. For many businesses, it might be very complex, time-consuming task to integrate visual GenAI to the existing workflows or solutions, but sometimes might be really outdated. It may be very pricey because it might require to implement new infrastructure, buy new software, hardware, and also hire people who can work with that and maintain. GenAI again is something to do with the customer data, for example, private data like photos, purchase history, etc., which again raises security and privacy concerns for the businesses and for the end users. And many businesses are concerned about the lack of understanding how GenAI in general and image inclusively models work. It is hard to predict the result, as you saw on Taras' examples. The models might be very biased, and it brings reputational risks for the brands or businesses. That's why it hesitate some business to onboard this technology. Regardless of plenty of barriers, market trends are suggesting that the businesses are willing to overcome those obstacles and actually apply visual GenAI. Those market trends that I'm gonna briefly share are inspired by McKinsey research as well as by insights from our own clients, by their requests. So what's going on? Now we can observe kind of new paradigm in customer experience. For the customer of nowadays, it becomes a new normal to have a digital experience integrated into a customer journey. Therefore, businesses integrating GenAI to e-commerce platforms and shopping assistants, etc. We will see some examples later on. Basically, to enhance that experience and improve conversion rates. GenAI is a powerful tool for personalization. We can see that. And businesses would like to allow customers to experiment with the product, basically online. It may be adjust colors, shapes, etc., and see the changes immediately. They believe that it would enhance customer engagement. GenAI also allows to create tailored marketing, basically when we can use the purchase or browsing history of the specific customer and generate a target message to him accompanied with appealing visual. And businesses believe that it can build a deeper customer engagement and closer customer relationships, because we're kind of trying to imagine what the customers like and then send in personalized message, and we expect they will be very happy and loyal. We can also observe that businesses are willing to use GenAI, image GenAI for process optimization. We can use this tech to optimize such processes as a design or content creation. Imagine how much you need to invest in order to create a nice product images. You need to hire studio photographer, then have a lot of things to do to process this information and create the final visual. Now the GenAI allows businesses to shorten this cycle and of course save costs. For some businesses, we know that visuals is a kind of business driver. We're talking about here about retail and e-commerce mostly. So what sells is a high quality, great image placed to, to the context that the potential customer wants to see. I'm talking about localization things and visualization of the same product in different conditions. Now we have to sum up kind of market needs that we scanned during this market research. We can see that the businesses are searching for cost-effective solutions to generate diverse, engaging, and custom visuals. They also searching for the tools to create consistent content. And as Taras mentioned, for now, it's a challenge, but we are working on it. You can see how many different content types exist, and it's really a big challenge for the businesses to stay consistent, as different people can work on different items, and also there are a lot of platforms that they need to handle. So it's really a big need and big demand. Digital content is saturated. So there is a statistics that 4.4 billion blog posts are published online every day. That means that the companies now have to produce much more and better content than ever. And businesses need a tool to create the visual content that would help them to stand out among that big number of competing content. Again, driven by innovations with AI, the world of SEO is changing. Now Google is going to update the ranking framework to reward sites that create highly original content, and businesses investing or relying on image generation or visual GenAI need a solution to address this issue. And of course, AI models explainability supported by AI regulation, ethical considerations to ensure that the models that the businesses are using is responsible and compliant. That's what they need. So that's a competitor's landscape. It's a it's a small piece of what's going on the market. But those are just some examples. Some of them are like addressing more general, like for more general use, and they are more known, like Midjourney, OpenAI, DALL-E 2 or GPT-Chat-4, but there are less known things. There are also plenty of tools solving a specific problem. For example, like interior design from image input, like this interior AI, or product design, for instance, a car design from sketch to a full visualization like Viscon, or icons design from text input. So what we can see here, there are a lot of competitors, but they are working on with a on the specific niche, and our goal as a team to find our niche and solve the problems that are not solved yet by the others. So now let's talk about more practical things, maybe about how currently businesses are using visual GenAI, what type of tasks they are solving. So most common things that used is automated image editing to adjust background or remove background, correct colors, lighting, etc. Image similarity search, when the customer can upload an image of a specific product and then find similar products in the internet. Virtual try-on experience. Also, they use a lot, including us, a GenAI output for ideation or creation of new ideas and concepts, designs. And some businesses are using visual GenAI to generate different versions of visuals for A/B testing. Now let's see some examples of basically case studies from the market. It turned out that GenAI is mostly used by the retailers, luxury, non-luxury. They're experimenting with visual GenAI in different ways. For instance, Prada used image GenAI in their marketing campaign for this fragrance this year, April, May, I think. Here is a source. You will be able to check the Instagram advertisement created as a fusion of photography by famous photographer and manipulated by GenAI. Gucci brand did the same for their fragrance. They used Dale for that, for instance. Another use case is integrating generative AI and visual GenAI into fashion assistants. So Zalando embedded it into their virtual assistant. Similar did the brands such as Zara, for example, H&M and Loft brands in partnership with Google created a virtual try-on. And the user can upload their image and then see the visualization of themselves in the clothing they selected. The retailer Revolve used visual GenAI to enable imaginative, futuristic billboard marketing campaign, which wasn't possible in real life. Like you see those gigantic mushrooms. Tommy Hilfiger used visual GenAI to enable co-creation opportunities during the Metaverse Fashion Week. So those are examples from real world. Now I would like to share a few examples about what we are doing. For instance, of course, except the things that Taras mentioned, talking about technical capabilities like denoising, style transfers, 3D object generation, we're also working on this use case where we can change weather conditions from the initial image input and text prompt as an input. This is a use case for retail mostly when you need to present a product in different weather conditions or environments, not necessarily always weather. The same goes for self-driving cars. In order to train the car, you can generate great data sets with the different weather conditions so that safe driving car is safer to drive. Another example is called product environment placement, but it's all about the thing that you can upload the image of the product and provide some textual input and generate these products surrounded by different background or in different environment. We know that businesses, they definitely needed different types of the visualization of the product for their marketing campaigns or product catalogs or whatever, or e-commerce. And of course, in different locations, they might need to present it differently. Yeah, another example is product design variations. So we created a model that allows to experiment with the product design, basically adjusting the colors, shapes, and other parameters. And so basically find the best look and shape for the product. And one more example, the use case is content localization. So we're also working on the model, that's an example, where we can generate different outputs depending on the location. So we can work with a gender, race, age, etc. For instance, for marketing campaign in Europe, you would want to have, as a person presenting this product, one person or one celebrity, but for the Asia, you would want to have a different person or face presenting that product. And this model would allow to create this for the marketing purpose very easily. Also working on some other things like or exploring the possibilities for multimodal generation, where we can use multiple inputs to create multimodal output. Also, we are exploring the possibility of converting 2D images into 3D objects, and actually much more. But for the sake of the time, I would like to offer you to ask questions.
Thank you, Anna. Also encouraged to ask the questions, if any. Overall, thank you for the presentation, Taras and Anna. I think the possibilities are endless, and in the nearest future, we will see even more, I would say, successful implementation of visual GenAI and text-to-image models for our clients and together with our partners. That's definitely what we can observe. And yeah, and probably it's possible to talk about use cases even longer, but still, even if you have use cases on your mind or opportunities that you find relevant, you can always drop a mail to us, and we can tailor the knowledge that Anna and Taras are unifying in our GenAI lab and R&D. So if any question, please ask. If no, you can always reach the, I see one question, 2 questions even, but for sure, you can always reach the speakers in direct. So the first question, what is the from Hennady Zaichenko, what are the mechanism for art content creators to remove their works from AI training data set?
Yeah, I will answer this question. So everyone knows the term machine learning, but recently the term machine unlearning was presented by Google, and there are different competitions actually to unlearn some data, because so actually there are approaches to make some networks like Stable Diffusion or something like this just to forget some previously learned content. we also, within our SoftServe R&D department, we have expertise in this. So if you're interested in this, and if you have some relevant use cases, please reach us. We would like to discuss them with you.
Thank you for the answer, Taras. The question from Jack Cherevcom: who is more target audience here, brands or rather creative agencies for the use cases you mentioned?
For the use cases we mentioned, this brands, like retail brands, marketing agencies. I think both, because it's all about creating a visual content. But to be honest, the visual GenAI is a very cross industry, because almost each and every industry needs a visual content to promote their company or product that they are working on.
Yeah, thank you for answering, Anna. Probably as we see now questions, a question from myself: how close are we for optimizing the models in terms of our existing requests that you can observe, of optimizing models, of compressing the models in order to achieve reasonable cost of implementation? It's rather just do this work manually, because it's always blocker for a lot of such new technologies and digitalization features.
So right now we are investigating different options. It's like there are two directions in terms of cost. It's actually like reduce the training cost, because to train like such huge networks, it's very expensive, or reduce the inference time, also to reduce the cost during inference. There are multiple ways for doing this. For example, for reduce the training time, we can use like some techniques like LoRa, and to reduce like training and inference time, we can use like tiny Stable Diffusion, for example, which will help us to probably get a little bit less quality results, but with higher efficiency, and with saving some costs for the business.
Clear, thank you. So as Max commented, awesome presentation, real eye opener. So thank you for both of you presenting for the topic of visual GenAI today. There is no question for now. If you have any, please drop a mail or reach Anna or Taras directly. Have a good day and see you in the next R&D Talk. Bye-bye.
Thank you, guys. Bye.